Yes, all right. So, welcome everybody. Hope you had such a good night as I had yesterday. I apologize for my voice due to yesterday night. There's the guy responsible for it, by the way. Yes, that as well. All right, so I'm going to be talking about a day in the life of Oracle Analytics queries today. Before we start, just quickly, who am I? So my name is Berg. I'm running a company called Dimensionality in Switzerland. We do analytics since quite a while now. I'm an Oracle Ace as well for analytics. I'm speaking all over the planet on these kinds of subjects at Oracle official conferences, user groups, Kscope, etc. And you can throw basically any question you have in terms of Oracle Analytics at me over any of the media shown here. And basically, I will respond almost 24/7. Right, so what are we going to look at today? So first of all, quickly, why am I doing this presentation? A little bit of a context. Then what does the packaging say? What does Oracle tell you when you buy a product? Well, not much, but what do you see when you look inside of the documentation a little bit? Then, okay, which analytics are you actually talking about here? And then the nitty-gritty, the actual day in the life of a query, execution details, and then just wrapping things up. So why this presentation? If you've been in my talk yesterday, you will know this slide. And basically, since Oracle Analytics products are around since quite a while now, it's widely considered a commodity know-how, meaning, okay, there's a lot of people doing it, there's a lot of people knowing about it, so we don't really have to invest time, money, or effort into it. It will just work. Well, no, there's a lot of people doing it out there, but there's not many people doing it right or correct or well. And for me, it's always, when you work with something, but you don't understand the actual underpinnings of the thing and how they work, well, for me, you can't really create the perfect system. It will always be kind of an approximation. And the last two ones, a little bit of joke in there. Just because something is cloud or black boxed doesn't mean you don't need to understand what's happening. You still need this. An alternate title for this presentation could have been A Normal Day on the Oracle TechNet forums. So these are the places where people come to ask questions about all the different products. For analytics, we have like about 12 different ones at the moment. And if you go in there, you will see a lot of things. Yeah, I get this error. I don't get an effect table at the requested level of detail. And I get this wonderful 14025 error there. Or I have this SQL statement because I was a report developer, and now I actually want to do this in the analytics toolset. Well, guess what? We do not work with queries. We work with models. We work with metadata. Wrong approach there. SQL to OBI. Implement the SQL to OBI. And this is literally, okay, logical table source settings. This is literally stuff that I collected over about 1.5 to 2 weeks of time. So it's amazing the level of misunderstanding and incomprehension of the tool set that's out there. And yeah, how do I write statements? So wonderful. I mean, and this is the second talk of a series of talks I'm doing, and if you've been in here yesterday, you will know these two slides. So basically, I'm going to go into the nitty-gritty detail underneath those two slides and explain, okay, what's actually happening there. And why do we need to explain this? Well, the culprit is this one, the repository file. So that's the metadata layer of Oracle BI. Who has seen a repository already and used it? 1, 2, 3. Yeah, a couple. Okay, that's good. So, as we all learned from that wonderful Spider-Man movie, with great power comes great responsibility. And there are 5 gazillion different options in here where you can influence what's happening, how data is mapped, how it's processed, how it's aggregated. So, you actually need to know this and how it works and what it does. So it actually helps you do your work. A customer comes along and says, hey, listen, I got a query that runs. A, it runs slow. B, it aggregates wrongly. C, oh, there's information from some star missing and the 2 others are appearing. I see stale data. Yay, cache. I mentioned it yesterday already. I hate that. Where do I have to go to actually find out what's happening, what's going wrong, which config options do I have to change so that it comes back correctly? And we'll see all this in the course of this presentation. And as I said, if you don't understand the underpinnings of the solution, you can't build a good solution, nice way, for your client, for your corporation, and for your customers. You will need this. Right, let's quickly look at what Oracle says. So we have the Common Enterprise Information Model with the 3 layers, physical, semantic, and presentation, and we decouple to the front end so that everything that comes along just transparently uses whatever we have underneath. Front end should not have to worry about, is this an MDX written cube in Essbase or Microsoft Analysis Server? Is this something written in SQL, in an Oracle database, in an IBM DB2 or something else? Or is this just an XML file or a JSON lying underneath it? So the source agnostic approach that we have, we don't care what's underneath. That's crucial to us. But obviously, as I said yesterday as well, you need to make the things and bits and pieces fit together. You need to tell them, how do you act together? How do you work? How do you get the data? And also, okay, which analytics are you actually talking about? Because if you look at the Oracle website, and if you look at what's happening in the different forums and the TED Talks and whatnot, I mean, these are just some of the Oracle products out there. So you got Visual Analyzer, BIEE, the most common one at the moment, data visualization, Oracle Analytics Cloud, BI applications, like, okay, what the hell? So just let's take one example. So Oracle Analytics Cloud, it's the newest one. It literally just came out a couple of weeks ago. So it's the new kid on the block. And I think most of you are too young to even remember those very trashy guys there. But if you get the joke, I think Brendan gets it. Unfortunately, yes. So yeah, Oracle Analytics Cloud, it's the new product in this whole family of things, and it's basically the full-blown product suite of all Oracle Analytics product propositions combined into a thing you can buy, and you don't have to buy BI Cloud Service on the one hand, you don't have to buy Data Visualization Cloud Service on the other hand, plus a database as a service, plus da-da-da-da. It's a packaged solution where everything in the Oracle Analytics space is just in one place and provided to you. So luckily I finally managed to get some nice slides out of Oracle on this because, as I said, literally came out a couple of weeks ago and it's still quite unknown. Plus, I'm now officially allowed to talk about it, which before we weren't, obviously. Right, so there's everything in there, and all these things like data mashups that we've seen over the last couple of years. You can upload your own Excel file and mesh it up with your curated information that's in Essbase, in your database, in any data source. That's really cool. And the other thing also is, this isn't, if you look at the product like landscape that I showed before with all these nice little buzzwords, you find all of these inside of the Oracle Analytics suite. So the data visualization, the more data discovery driven approach is in there. So you can give that to people doing their own self-service analytics in their own little department. You can give it to them. It runs on the same platform. Then you get the BICS, so the BI Cloud Services, that's in there. So the whole basically food chain of analytics and the whole hierarchy of analytics in your corporation, you can do that with the one product now, which is OAC. Right, so then you get some nice visuals. Obviously, everything is out of the box mobile. You can talk to it with natural speak, so you can tell it, give me the revenue for Germany in 2016 compared to France. And the toolset will actually, through the natural speak capabilities of your, for example, mobile phone, translate this and bring you back the correct graph, filtered, etc., upon request. Right, then you got data preparation features in there now. So you got cloud-based, let's like micro ETLs and data flows where you can mesh the information together already upon getting it into the system. You got predictive modeling, etc., etc. So you can look into this more in detail later on when you get the slides for this. But I really want to go on. So yeah, pattern, etc. It's really a very nice combined effort that they made. Right. Okay, come on. Right, let's go back to the offering itself, just to reiterate also from yesterday. We got the common enterprise information model. We mesh it up with external data sources and then deliver it through all the different channels there are. Right, and then there's one thing that is also gaining in importance. Yeah, we're actually going back to the desktop. So desktop analytics tools, like here in this case, Oracle Data Visualization Desktop, are actually coming back. So, you know, it's not just all cloud. People actually want to have stuff on their laptop when they're traveling. You're not always connected to a high-speed network. Sometimes you just want to manage your own data in your own Excel files on your desktop and analyze them. So the tool set is there, and it does a lot of things for you. I mean, even like advanced analytics with Oracle R, for example. And if you go there and you think, well, now you're talking cloud, you're talking stuff on the server, you're talking stuff on the desktop. Well, even if you look at the desktop and you run your task manager, you'll see 2 tasks in there. Well, if you work with the Oracle BI suite, you will know these tasks. And you're like, oh yeah, I remember those. So let's go a bit deeper. Let's go under the covers. Let's say, okay, how do I actually find out what happens here? How did I get to like the point of detail that this presentation provides? Is, well, you find this in rather old documentations. It's all right, we get query clients, the BI server in the middle, data sources, and then we go native or over ODBC to them, and well, we get the repository and the admin tool. Cool. Okay, but I'm not okay with that. That needs more detail. And then little archaeology, use this word because I found this one in a Siebel 7.7 documentation from around 2004, 2005. So you're like, okay, this is a bit more detailed, but still, we're just talking about requests, query plan. Well, especially this one, query plan. Well, that's vague. So yeah, Siebel Analytics Cloud, there's like 15 years between those 2 products. If we look at the architecture that's underneath it, and this is the really neat thing that we have. So this is 10G architecture, this is an 11G architecture, 12C, cloud. Well, guess what? At its core, most of the components have stayed the same. Most of the components still do what they do. I mean, yes, they're doing it a lot better. Yes, they're a lot more performant. They can get more sources faster with more functionality. But the engine, the intelligence behind it has stayed the same, which is really neat. So we don't have to reinvent the wheel at every single release. Which is also that this actual day in the life of the query. If we look at, okay, we start the workday, we're doing like some front-end and hoc analysis, or we're looking at some dashboards, or we're just taking our mobile phone and running BI Ask and tell me, okay, yeah, give me my daily status report of my team. So all of this works the same way because it uses a shared architecture. So we can actually map those 2 together and then look at, okay, how does it actually go from the one to the other? And here we're now going to go into the query flow. So we start with some kind of front end. Can be a browser, can be the Excel plugin SmartView that came in through Hyperion. Then we connect to the WebLogic managed server that's running this whole thing, hands it over to the presentation server, hands it over to the BI server. That one then says, okay, thanks, I'm going to go to the sources, I'm going to grab data. Sources give stuff back to the server, presentation server, managed, and then we're in the browser or in Excel or in, I don't know, your own handwritten application that's consuming web services. So that's really neat. We got it in terms of the flow. So WebLogic, we don't care. That's just the middleware. It's just running things. Then presentation server, yeah, of course, we're creating GUIs and whatnot and producing HTML output or web service. But here we should have as few logic as possible. The BI server, okay, this is the actual brain of the operation. This is where all the magic happens. This is where our requests get transformed into queries. And the workload, so the actual number crunching and getting the information, that should happen in the sources. Also, again, something I already said yesterday, as much as you can, please offload it to the source, because they're optimized for that kind of stuff. If you bring that 5 million rows or 5 billion rows into the BI server and then do an aggregation on it, yes, the server can do it, but personally, I'd prefer to get back 1,000 aggregated rows and then just do some nice fancy advanced analytics on it. And now let's go into the magic. So we had this flow that we've seen before, right? Well, we also have a detail architecture. That's actually the server internals. That's the entrails. And we're going to go through this because this is basically the structure that defines how queries are built and interpreted. And in order to do this, what we will use all the time is, hey, our friend, the log files. So if you have any question about why a query is slow, or why a query aggregates the way it does, or why it skips a star in a non-conform dimensionality query, well, the query log is where you go. It contains all the information you need in terms of the logical request, so just which columns, and then the physical request, so which SQL, which MDX are we actually talking about. Right, let's jump into the detail. So that's the detail of the detail of the detail that's now coming. The whole package is called intelligent request generation. And that thing receives the queries from the front end. Any front end, doesn't have to be Oracle Analytics. And hands it over to the logical request generation. So that actually says, right, so you'll need 3 queries, 3 columns. One of them is a fact, 2 of them are attributes. We'll have a where clause somewhere, maybe, but that thing doesn't actually write the query. You will see the actually writing of the query is like still 25 minutes away, minimum. So this is just a preparation stage. We're just assembling bits and pieces. And now, by the way, all the screenshots in here are made using the Oracle Analytics Sample Application Virtual Machine. It's a free virtual machine you can download. It comes pre-configured with all the Oracle Analytics products in there running, and you can reproduce all the steps I'm doing here on there. So it's not something I made up for this presentation. It's actually something they have been doing for a couple of years, which is really good. So they told me, yeah, okay, we actually do have examples in there for most of the config options we're going to use. So it's pretty neat. So here we'll see, right, we got something coming from an Oracle table and from an Essbase cube. We look at it, right, this is the logical request. All it says is we need something for a year, and we have 1, 2 revenues. And if I hadn't put these names in the logical name of the columns, then we wouldn't just be seeing, you know, revenue 1, revenue 2. We wouldn't know where it comes from. So the first step that happens is caching. It's a check, so optional. Is this enabled or not? If you're configuring your server, first of all, you can tell the server in general, hey, are you allowed to cache stuff? Yes or no? And in detail, every single object on the physical layer of the RPD can be cached, yes or no. If you do caching, very important, make sure you have a strategy of refreshing the cache as well. Don't just populate it. When an ETL comes in or a trickle feeder or something, make sure the cache is refreshed. Otherwise, your users will hit stale information. They will get the query back maybe in sub-second performance instead of 3 seconds, but it will be old data, so what's the point? Right, so there's a check being made. Does our request that's coming in match anything in our current cache database? So it doesn't need to be a one-on-one match. We can get subsets. We can get aggregates from the cache. So if we have, for example, months in the cache and we want to have years, it will be clever enough to know, get me the year, and do it on the cache, not on the database. We can also circumvent the cache, which is really nice for development and also bug checking in production. A user says, hey, listen, I have this query, it's coming back, but it looks like it's the data from last month. Could you please check? Well, yes, of course we can, because we're admins. We can actually go in and play with the system and say, well, we have this variable called disable cache. We set that to true, which then also gets written into the log file, and we will hit any data source that's underneath it. And obviously, if we then get on the different result than the front-end user and say, yeah, okay, someone is using caching, but is not actually doing a proper cache refresh strategy. Again, not something you should do. Right, so in terms of what's in the cache and how can we get this, as I said, we can do subsets. So in terms of select, a cache hit means it's either a perfect match across all columns involved or a subset of the columns. Same thing for the where clause. And obviously joins as well. So these are three defining principles. And let's say we run this, we just do a dimension only query to get all the years. And this is the first time it runs. This is the physical statement it does. Okay, perfect. And if we look more into detail in the log, we'll see, right, we actually have inserted this into a cache file, and this now lies on our file system. Cool. Other thing, obviously, you will see, well, better make sure that your cache files are lying on a very, very fast disk. Because if you put it on some old spinning disk somewhere, then you may actually beat your cache files with direct database requests. Then we do a subset query, a new one. We can see that the whole log is basically just, oh hey, I found a matching query in my cache, get it from the file, cheers, thanks, bye. And that's it. So rows returned to client just 2, and it came from the cache file, which is neat. So let's say we do not use caching, or, well, it's a completely new query that doesn't get fulfilled by anything in the cache. What happens then? Well, then the logical request generator actually goes down and says, hey, Navigator, could you please start doing your work? And, well, this is the brain. This is transforming whatever comes from the front end into backend speech. So it parses the BI server metadata, the wonderful complex RPD that we've seen before, and this thing decides on which logical table, and inside of that, which logical table source are we using. Are we doing aggregation? Are we doing post-calculation? Are we doing pre-aggregate calculation? Do we use dimensional hierarchies? If yes, on which level? So, and for this, it has 3 subcomponents. First of all, the multipass, sub-request one, fragmentation one, and the aggregates. And these literally now represent all the configuration options that you do in the repository in the middle business model and mapping layer. So this is why it's very, very important to actually build correct RPDs. Yes, you can go and just prototype things in a very dirty way, and the tool will allow it. But still, it would be optimal. So let's go back to our revenue one. As I said, we know that we have 2 different sources in there because it's actually in the name. If we look at now the query, well, yeah, we are in the subject area, federated sources. Hey, again, it actually tells us it's different stuff. But in the log, let's go a bit more in detail, you will see, all right, so we have a logical request. This is parsing now the middle layer of the RPD, and it sees, okay, in order to fulfill this query, I need to do a full outer stitch join between 2 logical data sets, one coming from the database Oracle, and one coming from the database called Essbase. So we're still logical. We're not writing anything here. We're not writing an MDX against the Essbase cube. We're not writing an SQL statement against the Oracle database. We're writing logical requests. So, and if we look at this in the RPD, how does that look? So we have our federated sources, and the first revenue column is physically mapped against LTS1 Oracle database. The second one, the gross revenue from Essbase, comes from Essbase. And the dimension that we use to combine those two are obviously mapped against both sources. So this is how we assure dimensional conformity over heterogeneous sources. The second place where you can force, or you can have forced logic is subrequests. Let's say we have these ratios here. And we have, what I also showed yesterday, these nice derived calculations, which means post-aggregate. This is something that's done by the BI server, not the source. It gets back data sets and transforms them. It doesn't get back row by row by row already the correct results and aggregates them. So if we have this, and we can see, okay, oh, this is actually a calculation based on a calculation. So it's a derived calculation based on a physical calculation, which means there is quite some logic in there. And in order to fulfill this, I need two distinct SQL queries against that data source. So that means we can't actually fulfill all the requests with one single query, even if they come from the same type of database, or sometimes even inside of the same database. Sometimes we have to have multiple sub-requests and stitch them together in the BI server, because the data just doesn't match in the source. So, second big part is fragmentation. Do we use fragmented sources? And here in this example, it's a weather analysis that is being done. So we got like hails, tornadoes, wind generally. And if we run this, then the request generator tells us, well, oh, listen, we actually have 3 distinct sources for this. They all look the same, but they are different. So let's go into detail. We already see, oh, 3 LTSs. This is nice. So why? Well, if we go into the content level, one of the very, very important tabs in the whole RPD, you will see that for the first table, we have this fragmentation content. So we have fragmented information in 3 different physical database tables based on type. So, for example, from one sort of weather station, we get back hail information. From another one, we get back wind information. From another one, we get back rain information. And we combine these. And that's why this little tick box here on the bottom, for example, is very important. That means, all right, in terms of weather, we get these different sources, but please stitch them together and provide them to us as one data set. You can have this, for example, if you say, in insurances, we have different business groups handling like corporate customers, private customers, just vehicle customers, just home insurance, etc. But we actually want to aggregate this information all together and combine it. Well, this is how you do it. This is how you get it together. You don't actually go in and, for example, write a union query. This is the equivalent of union things together in the RPD. So you never have to bother about, oh yeah, I forgot something, I need to make a new union request or write the SQL statement. That's the reason why we do all these models. So yeah, we map this, and guess what? We got the result set. And last check it does is the so-called Aggregate Navigator. I was talking a lot about levels and aggregates. Best example is always time. Everybody knows time. Year, month, quarter, yay. So in these logical table sources and the dimensional hierarchies that are tied to them, we define what do you contain. Do you contain information aggregated only on year level? Do you contain information on the day level, down to the second? Do you contain information on the customer level or just on the sales rep level? Is it country, etc., etc.? So the hierarchies play a very important role. And that's the reason why, for example, and this is another, let's say, abused configuration options, is these number of elements. This isn't something that you just set arbitrarily. We actually need that so that the Aggregate Navigator can decide what's the most efficient way to access the information, and then afterwards aggregate the information again, so going upwards. By the way, this doesn't have to be absolute numbers. So for example, year down to month, you don't have to say, oh, we have 500 years in there, so that means we have 6,000 months. No, it's ratios. So it's 1 to 12 to 365. That's enough for the internal optimizer to know. Then we have the LTS priority group, so logical table source priority group. In many cases, people come along and say, oh yeah, but we just have one source for everything. Well, good for you. But if you actually work with complex systems, that's not just some random 5 database tables that we pulled together and meshed up. If you have heterogeneous sources, if you have source systems with thousands and thousands of tables in there, you will end up with something that brings back information from different sources on different levels of granularity into one logical object. So this becomes important. That means which one is getting parsed first. And that's why we have the priority group. In this example, it just says, okay, everything is null, everything is 0. Right, so everybody's the same. Guess what? If this happens, it means another thing kicks in. It's a sort order. So that means first, highest priority is the day grain, then the month, then the quarter, and then the XML source. Personally, I wouldn't do this. Guess why? That's the highest aggregate. I actually would want to have this on the top in order of improved performance. And let's see how this actually looks. If we run, again, very, very simple query, just year and revenue, we'll see in the query, all right, it actually hits our quarter grain. It knows, all right, that's where it's the highest aggregate. Cool, I get it back. Then I drill down, and we'll say, okay, yes, I have to change my grain. I actually have to join a new table. Same thing will happen if, for example, you have aggregated information in an S-based cube and detailed information in an Oracle database. So the first query, let's go back, this would actually be an MDX statement going to the S-based cube. Then you drill down, and immediately it writes SQL against the Oracle database. So even if you're drilling inside of Oracle Analytics products and just going through your data, imagine you're an end user, you do not want to know that there's different systems on there. You don't want to know, okay, my first 2 clicks touched 2 cubes and my third click touched 15 tables. You don't care. It has to be transparent. Right, so now that we've done all this, we know where the data is lying. We know we have to do or don't have to do, hopefully, some multiplus or sub-request logic. We're using fragments or not. Where do we aggregate? At which level do we aggregate? And what do we aggregate? And by what? So facts and dimensions. Now we have all this information. And only now do we come to the part where actually, hey, we are writing a query now. So here we are now touching finally the physical layer of the RPD through the connection pool information, through the database features of those connections. The engine goes in and actually writes the query against the source, depending on, obviously, source type. As we've seen yesterday, there's a lot of those. I mean, just a couple of them. Also the source features, goes through them. And, very important, as much native function shipping as possible. So whatever we can do, we offload to the data source. We offload it to the cube. We offload it to the Oracle database. We offload it to the Hadoop storage. Obviously, you can't offload a lot to an XML file. That's the reason why we try to minimize the usage of those. So, then in the end, the results are getting back from the sources. They're combined and post-calculated as we needed. So, for example, if you have 2 physical SQL queries, we have an in-memory stitch join. If you have heterogeneous data sources, we have an in-memory stitch join, and then the BI server recalculates and retransforms that data set. It's written into cache, if we're using cache, and then it's passed back to the calling interface, meaning it goes back to the presentation server, and from there it goes to either Smart View, front-end, browser, web service, whatever. So, and with that, we're actually done. So, very important to understand here is the flow. This is what happens when you run a query. Inside of that, you need to know this architecture. What does the architecture do? And most importantly for you as developers, which one of these parts maps to which functionality in the RPD? And with that, well, if you got all of this, seriously, that's all there is to know. Sounds easy. If you grasp it, it is easy. So I'm already done for today. I kind of made up of my overtime from yesterday. I apologize for that again. So any questions? Nothing? Everybody's still asleep?
Right, thanks. A few questions. We maintain an OBI environment for quite a big customer. And there have been quite a few issues. One is that they run Siebel, and the segment tree won't migrate from 11G to 12C. So we're running 2 instances now. But that's another issue. We regularly hit, or have been hitting a problem with the dynamic repository variables. They stop updating. What we usually do is we restart the system, and it helps. But have you encountered this problem with 12C recently, or do you think it's quite a recent issue? So I've been wondering.
It's a recent issue on 12 for you?
Yeah, on 12 now.
Which 12?
12C.
There have been 4 so far.
Oh, right. 12's, I think in production, hang on. Because we only get it in production. We do quite a lot of development. I have to check.
So you said the migration was painful, or?
Well, we are running 2 systems now. The 11G, we run Siebel on top of that because the segment tree won't migrate. But reporting is in the 12C.
All right, okay. And so there you have then the dynamic variable problem.
Yes, yeah, in the 12C. So for example, date, yesterday.
Yeah.
I think it won't. I think we've had it twice now over the past 2 months. So it's probably something that is environment related. But
I'd say so, because honestly, I'm working with 12C since it came out and in the beta before that, and we never had this actually occurring. I'm pretty sure you've already opened an SR. And anybody from Oracle in here? No? Okay, which actually your SR didn't get you anything and it was useless?
Not yet, but we'll probably resolve it. I just thought to ask since I'm here now. So.
Well, honestly, there's quite some things that are very, very environment specific. We had those with, let's say, rather more weird operating systems. So I don't know what you're running, but I know I'm running into a lot of issues with Windows-based. Is it Windows? Yeah. Oh God. You have my sincerest condolences. Yeah, so honestly, most likely it's got to do with the operating system and the host it's running on. Yeah. Because normally we run this on different Linux machines, and never, especially that one, it sounds weird to me. It's not an area that normally problems creep up. So
yeah, that's why I thought we actually mainly do Click now, my Click consultancy, which helps a lot with OBI problems. I have another quick question.
Yes.
About this is more about the caching.
Yes.
In 11G, if I recall correctly, worked very nicely the automated cache purge. When an ETL runs.
Yeah.
I don't.
You called it over a file.
Yeah.
And then.
Yeah, I don't.
Yeah. Okay.
In my defense, I do project management and team lead, so I don't actually do much concretely myself anymore. But I think how it works is it writes to one of the tables, and then it automatically purges the cache when you do a rerun. For example, with
You're
ETLs.
using the polling tables in that case.
Yes.
Okay,
That's
that's one way of doing it.
Yeah, and that worked quite nicely with 11G. We never had to worry about after we'd done a rerun, if the cache was purged. But with 12C, there is some issue that we haven't been able to get it to work. Do you have any experience of this?
I tend not to use the polling tables.
Okay.
Because for me it's just yet another intermediary step. Which is kind of pointless because there's many different ways you can purge the cache. So you most likely write into those tables, and then there's a service picking it up and then going through it and da-da-da-da. So why do I say it's an extra step? Because there's functions, so Oracle API server functions that you can call either through the command line or through, for example, web services or whatever. I mean, there's 50 million ways of calling it. And it's a much more direct way. So what we normally do is we integrate the loading processes in a way that as soon as the loading process is done, it just says, okay, kill the cache, either for a given database or a given object or a given query if it's something hyper specific, if we're doing really like near real time, but still caching aggregate results or so. We do this function based, and whatever you use for ETL, so the tool basically decides which approach you choose, either the command line or a web service, because it depends on the tool. What can the tool do? But I really make it dependent on the process and not something that still goes into an intermediary staging ground. But again, you lose time. There's latency in there. Plus, if there's something failing, like, I don't know, it can't poll the table because there's no open connection pools and it's like in a queue or so.
That's a problem.
Yeah, so that's typically when in the configuration not enough resources in terms of connectivity have been assigned to the polling. So it just sits there and waits and going like, oh, there's so many users working on it, because that's the other thing. A lot of people tend to reuse the same objects for admin tasks and the actual request processing. So and then they conflict. And then you just go into the queue, all with the same priority, obviously, and just stand there and say, okay, I'm waiting. I'm still waiting, by the way. And the front end is very good at recycling connections. So if someone else comes along and your connection is still open, the next user will just use this. The back-end processes are much more, they actually queue, they're more like the British guys. They actually stand in the queue. The other ones are just like, no, I'm first, I'm just sandwiching in here and then. So that's a reason why I don't use the polling tables.
I think we'll have to look for a better alternative in any case, but we've got bigger issues now. So this is something that works. We just have a dumb kind of scheduled purge of the cache now, and then if we do have to rerun ETLs, then we'll just go and
of course. If it's time based, then but I mean, I can give you, well, you will have my contact details here anyway. So I mean, contact me. I'm doing this literally 25/8. So yeah, I'm pretty sure you can work around all of that stuff.
Yeah, this is they've been doing it internally, the DBAs there, and they're more focused on the back end. So now we've come in.
Yes, don't let that. No offense to any DBA in here, but don't let the DBAs do stuff like that.
Yeah, DBAs are great, but I think we'll handle this. Right, thanks.
No, I wouldn't let you do that stuff explicitly. No. Any more questions? Nothing. Excellent. So, in that case, thanks again for your attention, and please don't forget to vote. The organizers need this information. They have to know whether to invite me again or not. And enjoy the rest of the conference. 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 Enjoy the rest of the conference.